Hello everyone. Topic is oxidation of 3-degree alcohol by potassium dichromate in sulfuric acid. Its mechanism we will understand. Already we have discussed 1-degree and 2-degree alcohols. Topic is not for 12th class, for JEE and B.Sc it is. So let's start the mechanism. First of all, let me tell you, this 3-degree alcohol will resist to get oxidized by k2cr2o7 in normal sulfuric acid. Means dilute sulfuric acid will not work here. You require concentrated sulfuric acid and you have to heat it also. In this condition, you can make an effect on 3-degree alcohol by k2cr2o7. If you are using dilute sulfuric acid, it will not work there. So for 3-degree alcohol, these conditions are required. And even in these conditions, it will not get directly oxidized. First, it will show the process of dehydration. On its dehydration, firstly, it will create alkene. Now, these alkenes will get oxidized. Depending on their nature of alkene, they can create ketones, or aldehydes, or both. Aldehydes, ketones can be further also oxidized by k2cr2o7 as we know. So let's check its mechanism. For that, I am using this 3-degree alcohol. IUPAC naming, if you will check, you will find out it's 2-methyl butane 2-ol. It's a 3-degree alcohol, OH connected to carbon, which is further directly connected with 3 carbons. So in K2Cr2O7 and sulfuric acid, concentrated sulfuric acid, firstly it will show the process of dehydration and how that concentrated sulfuric acid will provide H positive particles. They are electrophiles, want electron, who can provide electrons, oxygen, due to which oxygen will make third bond with hydrogen and it will become unstable because third bond will be a dative bond. Out of 2 electrons, 1 electron it will completely transfer toward this hydrogen. Due to instability, it will start breaking bond from carbon. Electrons will transfer toward oxygen because oxygen is more electronegative, due to which a carbocation will be generated. Let's release out the water molecules. H2 will release out, stable compound. Now this carbocation can be satisfied by this carbon, and this carbon. We will satisfy it by this carbon majorly because the alkene which will generate here, it will be a stable alkene. How to generate alkene already we have discussed many a time. So in detail I will not go. This carbon will break bond from hydrogen and will shift electrons to satisfy this vacant orbital, due to which between these 2 carbons double bond will generate and this alkene will be generated. H positive ion will release out, which will repeat the whole cycle again with another molecule of ethanol. Alkene is generated. Now this alkene will be oxidized by K2Cr2O7 and sulfuric acid. Let's check how its oxidation will be done. Number 1, first let me recall, when K2Cr2O7 you dissolve in sulfuric acid, it create this chromic acid. This chromic acid will oxidize whatsoever you want to oxidize. In yesterday mechanism, I have told you how k2cr2o7 will react with sulfuric acid and will create chromic acids. These chromic acid particles will oxidize alkene. Check previous video, you will get it. Now the alkene which was generated here, in this case, it was that I am drawing. If you have understood the previous mechanisms with KMnO4, with k2cr2o7, 1 degree, 2 degree alcohol, then you will find out almost all are same, little bit different they have. This is chromic acid. Now in previous videos also we have used it many a time like this. Now chromium in its chromic acid, what is the oxidation of it? It is +6. 1, 2, 3, 4, 5, 6. 6 electrons it is sharing with highly electronegative atom. You see these 6 electrons are going toward oxygen, so that's why it is +6. +6 charge will make it strong electrophile. It have a tendency to attract electrons. Which electrons are available here? Pi electrons are available here, these electrons. But these pi electrons will not directly go to chromium because it is surrounded by oxygen already. So they will go like this. Pi electrons on this oxygen, and these pi electrons will be further shifted toward chromium indirectly. In previous mechanism, I have also told you whether it was of KMnO4 or k2cr2o7, we have discussed it. Now because this carbon is losing its electron, this electron, so positive charge will come around this carbon with a vacant orbital, which will be satisfied by this oxygen by shifting bond here. So in next step, we will have this molecule. Here bond will generate between carbon and oxygen. This double bond will become single. Here we have already CH3. Between this oxygen and this carbon, bond will generate this one. Now here between chromium and oxygen, single bond will left because this pi electrons are shifting. These pi electrons are shifting to chromium. These are going that side. So single bond. And these 2 electrons will come on chromium. OH as it is, OH as it is. What we call it? We call it cyclic chromate ester, and you know this cyclic chromate ester will make this bond weak because of crowding and its cyclic structure. It is making this bond weak. Finally this bond will break. And how it will break? Either you can shift these electrons to that side, or you can shift these electrons to that side. Same product will generate. If I am shifting these electrons to that side because oxygen is more electronegative, so it is attracting electron, here double bond will generate, and we know oxygen is stable with 2 bonds. So this bond will break and these electrons it will push toward chromium side because these electrons are coming, they will repel them. These electrons will go to chromium. Here when this bond will break, you can check this electron is going toward oxygen. So this carbon will have a vacant orbital with a positive charge, which will be satisfied by this oxygen by bringing these electrons here. In this fashion bonds will break, and finally what you will get? This carbon will have double bond. Between these 2 carbon bond will break, so plus sign I am writing. Between this carbon and this oxygen double bond will generate and CH3, and this chromium will release out in this form. Please calculate oxidation state of chromium by yourself. So what is generated here? This is ketone and this is aldehyde. We know ketones and aldehydes can further oxidized by k2cr2o7 mechanism we have already discussed. you please apply the mechanism and further convert these products into carboxylic acids. That's it. This is the end of the video. In this fashion, 3-degree alcohols will get oxidized by k2cr2o7. Only the point to be remembered here that we need concentrated H2SO4. Dilute sulfuric acid will not work here, and even in this condition, first the 3-degree alcohol will dehydrate. Alkenes will be generated, and those alkenes will be oxidized by cyclic chromate ester. Thank you very much for watching the video.